Hey, welcome back. Have you ever really thought about what happens after your bank locks its doors for the night? You'd probably think everything just shuts down, right? Well, that's actually when the bank's most powerful, most critical systems kick into high gear. Today, we're going to pull back the curtain on the hidden world of mainframe end-of-day processing.
All right, so here's what we've got on tap. We're going to start with what's actually going on while we're all asleep. Then, we'll get into the difference between the bank's daytime and nighttime personalities. We'll look at the incredible nightly symphony of tasks and what happens when something goes wrong. And to wrap it all up, we'll see how this supposedly old tech is absolutely essential in our modern world.
So just picture it for a second. The bank branch is dark, the lights are off, the mobile app is quiet. But what about all those millions of deposits, transfers, and purchases that happened all day long? They don't just hang out in limbo waiting for the sun to come up. Nope. Something has to take all of that data and make sense of it, and it has to be perfect.
And that something is the mainframe. It is the absolute workhorse, the unsung hero of the financial industry. While the rest of the world is sleeping, this machine is tackling the gigantic job of processing the day's controlled chaos, making sure every single penny is accounted for before the doors open for the next business day.
You know, to really get a handle on what's happening at night, you got to understand that a bank's computer system kind of lives a double life. It's like a restaurant, right? During the day, the chefs are cooking individual orders as they come in, one by one. But after closing, that's when the whole crew comes in to do the heavy-duty prep and deep cleaning all at once, in one massive go. That's pretty much the difference between online transaction processing and batch processing.
And this slide really breaks down those two different worlds. Daytime is all about OLTP. That's the stuff you do. Swiping your card, using an ATM. It's instant, it's interactive, and it handles one small transaction at a time. But the nighttime? That is for batch processing. There's no person waiting for a response. The system just gathers up everything from the entire day and processes it in one enormous heavy-lifting operation. Now, this nightly batch process isn't just a random to-do list. Oh no, it is an incredibly precise, highly orchestrated sequence of events. Think of it like a symphony, with a conductor making sure every single instrument, every single program plays its part at the exact right moment. And the conductor of our symphony is something called the job scheduler. This is the master program, the brains of the whole operation. It dictates the exact sequence for everything. It knows you can't generate reports until you've calculated the interest, and you can't calculate interest until you've posted all the day's transactions. It makes sure there's order, not chaos.
And you can see that dependency right here. It's basically a chain reaction. The output from step 1, validating all the data, becomes the input for step 2, the calculations. And the result of that feeds into the next step, and so on and so on. If even one link in this chain breaks, the entire process grinds to a halt. So what exactly are these critical tasks? What's the music this orchestra is playing every night? Let's dive into the core mission of this end-of-day process and see the things that absolutely positively have to get done.
First up, a huge one, interest calculations. And believe me, this is no small feat. The mainframe has to churn through literally millions, sometimes hundreds of millions of different accounts and apply the exact right interest for each one. Different products, different balances, different rules. The scale is just staggering, and the accuracy has to be 100%.
Okay, this next step, this is the moment of truth for the entire day. It's called balance reconciliation. This is where the system confirms that everything adds up. The total amount of money that came in must perfectly equal the total amount that went out. It is the single most important integrity check to make sure the bank's books are perfectly balanced.
Once everything is reconciled, we get to the general ledger posting. You can think of this as the point of no return. This is the moment the day's finances are carved into stone. It's the official, formal accounting step where everything is permanently recorded in the bank's master books. The business day is now officially and irreversibly closed.
And it doesn't stop there. On top of all that, the mainframe is also busy calculating things like credit limits and market risk, getting huge reports ready for government regulators, generating all of our monthly statements, and of course, settling up accounts with thousands of other banks. The sheer scope of the work is just immense. So you have this incredibly complex process, running millions of calculations every single night. It's kind of inevitable that sometimes things are going to go wrong. And because this process is so critical, you can't just say, oh well, we'll try again tomorrow. So, how do you manage failure?
Yeah, let's ask that question. What if one of those jobs in that critical chain fails at 3 o'clock in the morning? The bank's ability to even open for business is suddenly on the line. Do they panic? No, because there is always a plan.
And that plan usually involves two main tools, a restart or a rerun. A restart is for the simpler glitches, like if a resource wasn't available for a second. The job just picks up right where it left off, from its last successful checkpoint. Super time saver. A rerun, though, that's for more serious problems, like if the data is bad or there's a bug in the code. In that case, after a fix is made, you have to start that entire job over from the very beginning.
Okay, but wait, that brings up a massive question. How do you rerun a job without, say, accidentally paying someone interest twice? Well, the answer is an absolutely brilliant design principle called idempotency. It sounds complicated, but the idea is simple. Running a process once has the exact same result as running it 100 times. The program is smart enough to know what it's already done, so you can never have duplicate transactions. It's a non-negotiable safety net for the entire financial system.
You know, there's this really common myth that mainframes are these dusty, old dinosaurs just sitting in a basement somewhere, completely disconnected from the world. But that could not be further from the truth. In reality, they are completely woven into the fabric of the modern IT world.
Just look at how these worlds connect. A nightly batch job finishes, and it triggers a modern API to send a notification to your banking app. A newfangled cloud system needs to know your exact account balance. It calls back to a program on the mainframe for the answer. And all that data that gets processed overnight, it gets fed right into modern data lakes to be used for things like AI and business analytics. Because when it comes to reliability and security, the mainframe is still the undisputed system of record, the single source of truth.
So, if there's one thing to take away from all this, it's that the mainframe's end-of-day process is not some dusty relic. It is the incredibly resilient, ridiculously high-performance engine that is still beating at the very heart of modern banking, night after night after night.
And that kind of leaves us with one last question to chew on. In a world that's obsessed with the next big thing, isn't it fascinating that this so-called legacy technology isn't just hanging on, it's actually the foundation for what's next? Makes you wonder what other secrets these systems hold for the future of finance. Thanks for joining me.